It is 7-5. All right. All right. Sit here. Can I sit here and teach?
Yeah.
Sweet.
Interactive teaching today.
All right. So, page 52, 7-5. You with me? Sweet. All right. Let's see. Is that, make sure that's active? Yes, that's active. All right.
I go ahead, Geo.
Yeah.
And the album comes out after.
All right. So chi-squared test of independence. Yay, independence.
Yeah.
All right, part 2, I guess it says. All right. So once you've calculated chi-squared, you can add them up. You get the chi-squared CDF calculator for a p-value to make the decision to reject or fail to reject. Remember, this is basically our foundation. This right now will also count as if they give you an alpha. Okay, so we're continuing with the categories with the ocean and all that kind of stuff. So they have the Atlantic, they have the Pacific, they have the Indian. They have categories 1, 2, 3, 4, and 5. And 20, 16, and 10. So there's 46 down here. 16, 8, and 4. So there's 38 category 2s, 10, 6, 2. There's 11 category 4, 5, 5, and 1.
3 is 18.
What?
3 is 18.
It sure is. Thank you. And then that is 11 and 2, 4, 1, which is 7. And then we have 53 as a total over here, 39 as a total over here, and 18 here. So we have 110 total scenarios. So in order for us to use this, we would have basically our chi-squared, huge value, and then degrees of freedom, right? We've used that before, but now we have to figure out how we are going to determine the degrees of freedom. Okay, now degrees of freedom originally, when we just had like one category, or we had, in this case we had 3 categories and we're just looking at category 1, we ignored the rest, our degrees of freedom would be 2. But the degrees of freedom with this is the number of rows minus 1 times the number of columns. Columns minus 1. Okay, so number of rows, we have 3 rows. Number of columns, we have 5 columns. So that gives me 2, that gives me 4. So our degrees of freedom would be 8. Okay? So if we went through the information on finding our chi-squared information, I'm just going to give you that. They tell us that they found that the chi-squared was 4.662 by going through the chi-squared stuff. And we said that we have degrees of freedom being 8 in this case. So then we can just go chi-squared CDF. So 4.662. Do like 1,000 or 10,000 degrees of freedom 8. We plug those in to the calculator. Let's go standard seconds. This chi-squared CDF. So we said 4.662. Upper, we said like 1,000. Degrees of freedom, we said 8. Paste. So that gives us 0.793. Okay, that's our p-value. So 0.793. This comes out to 0.793. And I don't believe they gave us an alpha value, if I'm not seeing that right. So is P greater than is greater than 0.790 or 0.05? So if I plug that in, does that make that true or false? Yeah, so we are going to fail to reject the null. I think we had done the null back there, that these were all equal. I think that's what we said the thing was. And the alternative is they are not equal. Okay, so it failed to reject the null. So pretty big p-value there. This is very high, which tells us distribution we're seeing could easily occur by random chance. P-value is greater than the reasonable value of alpha, which we said is 0.05. So we fail to reject the null. That's what we said. There's not strong evidence that this data, that the ocean and hurricane intensity are dependent upon each other. Okay, this is the test for independence. Informally, it tells us we cannot use one variable to predict the other. An Indian Ocean hurricane is as likely to be a Category 5 as any other hurricane, for example. The assumptions are the same as the goodness of fit. Sampling must be random, and each expected value must be greater than 0.05 or than 5. In the scenario, the random sampling assumption is hard to check. Are these hurricanes truly random sample of all possible hurricanes? One thing is clear, however, many expected values are less than 5. This is a chi-square test we wouldn't put too much faith in. Okay, so friends, do we look at weather patterns and make assumptions off of them? Yeah. I imagine there's some really good statistics that could be done. Hopefully it is being done to determine whether we have climate change of some sort versus not. I've heard arguments on both sides. I think both arguments are incorrect because they're not using any statistics. Okay? Things that I've seen as far as the climate change. I was up in Banff, Canada, and we were at this beautiful park up there that they had these glaciers. And so we were walking on this trail to get up to where the glacier was. You know, this is all ice, baby. Okay? And I thought this was pretty interesting. So at the very start of the trailhead, it said 1860. And then you walk a little bit further, and I'm making these values up. I don't remember exactly what they were. And this said like 1910. And then here it said like 1940. And then here it said 1960. 1960. And then that was probably the last one. Then you get to the glacier. And at first, you didn't really realize what these were. But this was the year where the glacier had been. And I can tell you that the distance of this trail was about 3 miles. Okay? So I think that that's a really good representation of, yeah, the ice is melting, but the only thing I could probably say is the glacier is melting. I can't say too much more based on the data they gave me. So that's kind of a back in the, I don't know, when did we go to Banff? There 5 years ago, I guess. If you haven't been to Banff, Canada, it's a pretty town, but oh my gosh, bring lots of money because it's expensive up there. Go to McDonald's, they don't have the dollar menu, they have the $5 menu. Really? Yeah, it's the same as our dollar menu. All right, so let's, I think we can give you the rest of the period to get this done. So page 135, 136, you can work on this for the rest of the period. I will mark that off tomorrow. We'll go over tomorrow as well. And let me know if you have any questions. Happy to help you.